Hello, all good people of the world. This is Paul Whittakin returning to you today with the periodic table of mathematics and the universal law of numbers and the universal math that I do with my universal law of numbers. So the first thing we're going to do today is we are going to just look at this again and refresh our memories about what I am talking about. And I will also bring out this one. And what this one is this is the universal law of numbers with the numbers not reduced. And one of the first impressions that we can get is we can begin to see a problem because these numbers, right from the get-go, they all of a sudden, they get to be pretty large and quite difficult to deal with, and we're just on the first go-around. So one of the main powerful aspects of the universal law of numbers, the periodic table of mathematics, is how it simplifies and it shows us the codes, and the codes are 248751, which are 258 and 714 and 818 respectively, which are the 369 code. And no matter how large the numbers get, even if we're talking about the exponents, it's still going to follow that same code. And that's the beautiful, powerful thing about the universal law of numbers. So we can understand the universe on the scale of the universe instead of on the scale of our human conceptions. So the first thing I'm going to do is I'm just going to remind us about the multiplication table, which is this right here. And once again, we have the 248751 code going across, the 248751 code coming down, otherwise known as the 369 code, and that goes on to infinity. And then I just reduce the numbers, and it shows that how that happens. And then I point out that the 3, 6, and 9 numbers created a symmetric pattern like that, and the non-369 numbers 248751 create a schematic like that. And if we look at them together, we see a building block. And that's building block number 1. And when we're talking about the universe, I'm talking about the building blocks of the universe. And that's what the universal law of numbers is. They're the building blocks of the universe, and hence the universe itself. Now, I conjecture that I'm no different than anyone else. The first time that I was introduced to the numbers 1 through 9 and the teacher wrote a 10 on the blackboard, I saw 1 all over again, as I conjecture everybody else did too. When I saw an 11, I saw 1 and 1, and I saw 2 all over again. And then when I started playing with the numbers, when they told us to write them on the paper, and we did 1 plus 1 is 2, and 1 plus 2 is 3, etc., etc., I had the sensation that I was working with the building blocks of the universe. That was just my intuition. That was just my instinct. And as all other people in the world, we all have the same instinct, and our instinct actually was serving us right. Now, Nikola Tesla, the person who inspired me to help to find this code, I'd given some considerable thought. I wasn't looking for the code per se, but when I stumbled across it inadvertently, I guess maybe I really was. I don't know. But anyway, he made the famous statement that the numbers 3, 6, and 9 are the keys to the universe. And I think what he was actually saying was what I am saying, that the 369 code, it actually is the universe. So intuitively we understand that, instinctively we understand that, and because of that, I'm not saying anything that we don't all already know. Okay, so I'm just going to leave that at that. Now, there are other theories that we have in this world. Among them, Bohr's model of the atom, the Heisenberg principle, uncertainty principle, Pauli's exclusion principle, laws of motion and thermodynamics, and, most notably Maxwell's equations, Newton's equations, and of course the theory of relativity. And what I have here is something along the lines of the theory of relativity too. However, mine is not so much of a theory, it's a gift from the universe, and I share it with people. And I think it's a gift and it's a knowledge that everybody can understand, because I believe intuitively everybody can understand this simple diagram, from the time you're in first grade, second grade, to however long you spend on this earth, you can understand the simplicity of this. And this is our number system. This is the way it works. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And it's a revolving cycle, and it goes on to infinity. So I'm going to go back, and I'm going to put this back up here again for a second. And what I'm going to do today is I'm going to point out the perfect squares. And reason being, because the perfect squares, they also show us the building blocks. Now, when we're thinking in terms of the magnitude of the universe, this mathematics that I perform, we can call it universal mathematics. It's really a very high form of mathematics, and it doesn't require a calculator. And these numbers that we write, as human beings, that get larger, larger, and larger, and take them to, the power of some larger and larger amount. All of that is just infinitesimally small on the scale of the universe. And in order to understand the universe, we just have to understand the language that it provides to us. It provides us with the codes 248751. So now, 248751, which is 258, which is 714, or 417, or 147, and 181, 181. It's a universal language that everybody can understand. And the universe is providing us with that simplicity so that we can understand what's actually going on. Okay, so what I did was I just took this right here and I looked for the numbers that were the perfect squares. And it comes out with something that looks like this. And this is before I reduced the numbers, and you recognize all of those numbers. They're the perfect squares that we are familiar with in mathematics. And people who are not familiar with the perfect squares, they're just numbers. If you, for instance, 6 times 6 is 36. So the number 36 is a perfect square. Any number that results in two other numbers being multiplied by themselves is a perfect square. So, of course, I reduce the numbers. And when I reduce the numbers, I see something that looks like a schematic like that. And we can also see that that's a building block. And we can also see the codes reappearing. 149779419, that's the first line of the periodic table of mathematics. 189, 189, 189 is the second line going across in the periodic table of mathematics. And we can see 248751. And we can see that the row going down, the first row, the fourth row, and the ninth row are the rows that have all perfect squares. So what's going on here is this. We're at 149, and we're at the very initial, these are the initial building blocks of the universe that we're speaking of right now. Just like that multiplication table was showing us the fundamental building blocks of the universe. Well, we're at the stage of germination of a seed. We're at the stage of the first cell dividing. We're at the stage of the simplest atom, the hydrogen atom. And that's what I'm trying to point out. These are the numbers that are the non-perfect squares, and we can see the symmetry in that as well. And that's when I'm asking people to observe just the symmetry, because the universe provides us with that symmetry, and that's something that everybody can understand. And if I put them together, I see that the perfect squares are surrounding the non-perfect squares, and I call them, or I refer to them as building blocks. Okay, so that's not really in order right there. So what I will do is I will go to the next page in the sequence. And what I've done here is, okay, so in the initial universal law of numbers on the first page, we go 4, 8. This is 16, 32, 64, 128. So this would be 256, and that's where we're at now. So we're starting the second page. So we have 16 squared is 256. So these are the perfect squares that occur on the second time around, the second revolution. And we come up with 179449719, which is the third line in the universal law of numbers table. And we have 159729489, which is the fourth row. And we have 119119119, which is the fifth row. And we have 248751, and we have the 9s, and we have 181, and we have 741, and we have, that's what we have. Okay, so, well, I want to point out something so we understand what I've done here. When I simplified here, I just took off the hat, so to speak, the square, the exponent, and then I reduced the numbers, and that's how I come up with these tables. So on the second time around, second revolution, we have those are the perfect squares, these are the non-perfect squares, and if we put them together, we also come back with what I would refer to as a building block of the universe. And now what I'll do is I'm going to do the perfect cubes. So on the first page, the first time around, the perfect cubes look like that, and I'm demonstrating how I came across them. This number here would be an 8. So when I go to the next page, what I'm just doing is I'm taking away the exponent. That's all I'm doing. And in so doing, we come up with this schematic, which is another building block, and we see another set of numbers we're familiar with. 1, 2, 3, 4, 5, 6, 7, 8, 9, and we have 1, 4, 9, 7, 7, 9, 4, 1, 9 down there, and we have 2, 4, 8, 7, 5, 1, and we have the 1s. And if I show you the non-perfect squares, they're going to be looking like this, and if I show you them together, they're going to look like this. Let me get this out of your way. And if I go to the second page, and once again, it's a building block. And if I go to the second revolution in the universal law of numbers, and that's where the cubes are in that arrangement, and I reduce them in the same manner, I just take off the exponent. And I get the 189189, and now we have a little bit of a different sequence. So I would say something is moved just simply one notch. So even though these numbers are starting to get bigger and bigger and bigger, we're just making a slight dent in the calculations. And this is what the non-perfect cubes look like. And if we put them together, this is what the perfect cubes look like. And now we're going to just maybe acknowledge that the universal law of numbers, periodic table of mathematics, is giving us mathematics that shows us the building blocks of the universe. And now we're just going to examine these codes just a little bit. Now, I often stumble when I'm giving presentations, and I don't edit these things. I've made videos that I did not publish because I just, make too many mistakes. But I hope people can bear with me and throw me the bone on occasion, because I will say some things and I'm trying to communicate a very, profound message, and my arithmetical errors are insignificant in the grand scheme of things. But anyway, when we have this 248751 code, It's a combination of the 147 numbers in any order and the 258 numbers in any order, and it's important to recognize the difference between having those codes in that order and the way that those numbers interrelate with each other as compared to mixing them up. Because as long as you stay with the code 147 or 714 and the code 258, you're always going to combine them and receive a 369 number. And that's what I'm showing here. So I've added 7 to 8, which is 15, 1 and 5 is a 6, 1 to 2, which is 3, and 4 to 5, which is 9. And I'll just demonstrate that a little bit more with some others. So we're keeping these numbers 1, 7, and 4, and 5, 8, 2. That's how we split up the 2, 4, 8, 7, 5, 1. And using that method, we get 369 numbers. And I just show it with, moving the numbers around, and we're getting 6, 3, 3, 6, 9, 9, 9, 3, 6. They're the 369 numbers as compared to the 2, 4, 8, 7, 5, 1 numbers, because the 2, 4, 8, 7, 5, 1 can give us any number. But if we stick with these two codes and add the numbers, they're only going to give us 3, 6, and 9 numbers. And that's what I'm pointing out here. And I'm just showing that to you. And we have more of the same thing, and we have more of the same thing, and it continues. I don't know what I did there. Looks like I forgot to write a number. I don't know. Be 7 and 8 is 6. 1 and 2 is 3, and 4 and 5 would be a 9. I don't know. Okay. So anyway, now the 2, 4, 8, 7, 5, 1. Now they can be a 9 too. But anyway, in this, if I add 2 plus 4 plus 8, I get 2, 6, and 8 is 14, 1 and 4 is a 5. If I add 7 plus 5 plus 1, we get 12, and 1 is 13. That's a 4, and 5 plus 4 equals a 9. And here I just show it like that. 2, 4, 8, 7, 5, 1 with the 147 and the 258 gives us the set of numbers. So the union between those two sets gives us 1, 2, 4, 5, 7, 8, which is 2, 4, 8, 7, 5, 1. And I think I'm just going to leave it with that today. That was short and sweet, and I wish everybody in the world peace and happiness.